right? So these are the objectives of chapter number 4. Basically, this chapter is mainly dealing the moment. First of all, we'll try to discuss the moment in 2D as well as 3D, then moment of a couple, and then the resultant of non-concurrent force system, and lastly, how can we reduce a simple distributed loading to a resultant force from a specified location. So let's start with the fundamental definition, right? Moment of a force. What is moment of a force? Basically, we can discuss that moment of a force in scalar formulation as well as in vector notation. Scalar notation, I mean moment of a force using the scalar formulation, that's mainly used in 2D system, right? Whereas the vector notation, that's used for mainly three-dimensional system. So scalar formulation is mainly for 2D application, and vector notation is mainly used for 3D application. Now, let's start from the definition. The moment of a force, as you already studied in your high school, that basically this is the tendency of a force to rotate a body about a point that is not on the line of action of the force. So we also call this as a torque, but most often it is called the moment of a force or simply the moment. Right? You can use any of the three out of three terminology. You can also say a torque, you can also use a moment, or you can also say moment of a force, right? So that's the mainly concern in this chapter, moment, we can say. For example, this is a ratchet, and let's say anyone applying a force and that's trying to rotate that body. So force about the this axis or about point O. So that means this is the moment of this force. So the moment of this force, that is represented with capital M, and when we return it as O, that means moment of this force about the point O. So that's basically related with the force, and this is called moment arm. This D is called moment arm. Moment arm is the perpendicular distance between the point of application and the line of action of that force. That's called the moment arm, right? So moment arm is very important. I mean the moment is always produced between the moment arm and the line of action of the force. So in order to produce the moment, the maximum moment, then there will be a perpendicular distance between that, also called the moment arm. So moment arm and the line of action of the force should be at 90 degree or perpendicular to each other, right? And you can see now the force is no more a perpendicular with reference to the point of rotation, but we need moment arm should be a perpendicular distance between the force, line of action of the force, and the point of application. So in this case, it was already at perpendicular distance, but now it is not a perpendicular distance. So that means we need a perpendicular distance here. So if this is D, let's say the force is making an angle theta. So the perpendicular distance is D sine theta, right? This is called D sine theta, right? So now D sine theta is the moment R now, which is perpendicular to the line of action of that force, right? And now you can see in this case, let's say, I mean the the force is, I mean that force is now parallel to the line of action of that line of action of the force is parallel to the moment arm, right? So now you can see this is a parallel to the moment arm. So in that case, you cannot produce any torque or any moment, because force and the moment arm, they are in the same direction, or in other words, the angle between the moment arm and the force is 90 degrees. So there will be no moment produced by that force. So in order to produce the moment by a force, the line of action of the force and the moment arm should be perpendicular to each other. Similarly, this one, d sine theta, is the moment arm which is perpendicular to the line of action of that force. Now we can see some practical examples. For example, here is a beam. You can see that that's a I-beam AB, which is lying on two end of a wall, and if we apply a force F, now can this force rotate that beam? What do you think? Can we rotate this beam with the help of this force?
No, sir.
No. So that means basically torque, you can also say torque is a tendency of this force. I mean, although it cannot rotate, but this is the tendency of the force, right? So again, if this is the force perpendicular distance, let's say if we want to calculate the moment about point A, then the perpendicular distance between point A and the force is this much is the perpendicular distance, right? So there is possibility that this force can rotate this beam about A axis. So we'll say the moment produced about point A, the perpendicular distance and the line of action. Similarly, there is a tendency that this force can produce moment about point B. So again, that means this moment produced by that force is in the counterclockwise direction, right? So there should be a reaction which comes in the clockwise direction in order to keep this beam in equilibrium, right? If there is a, I mean, torque in the counterclockwise, there is a reaction moment from that beam in clockwise direction, which can balance. That's why the beam is in the static condition. Similarly, you can see another example, for example, of FH mean the force applied by the hand, right, to pull this nail from that wooden piece. That means this force is, applying in the upward direction, right? It is trying to pull the nail in the upward direction, whereas the reaction force, the normal reaction force, will be in equal and opposite direction, right? Again, this is the point O about which there is a tendency that this force can produce a moment, right, about this point O. If you apply force, then there is a tendency that this nail can be rotated. Tendency mean that can be possible, or because we are studying the statics, so we will assume that there is a tendency, right? But in dynamics, you will assume there it has already rotated. I mean, the acceleration can produce this force. But for statics, we'll assume that this force has the tendency, but not rotated. Now, this is the magnitude of the moment, which is equal to Fd, right? Force and the moment arm. And how to figure out the direction of this moment, will use a right hand rule, right? What says the right hand rule? If this is the applied force, let's say F about point O, and this is the moment arm, let's say D, then the direction of the moment is perpendicular to this plane, right? You can use a right hand rule. Like right hand rule mean uh, the curl of the finger, this curl of the finger is the rotation of this force about point O, right? This one, and then the direction of the thumb will indicate the axis of the moment. So moment will be perpendicular to the plane of the force and the moment arm, right? Let's say again, this is the direction of this. So let's say if you reverse the direction of the force, right? If you reverse the direction of the force, then what will happen about the direction? Let's say if the force is applied, let's say here in this direction, right? Let's say in this direction, and the moment arm is now this one. So where is the direction of moment now? What will be the direction of moment now? Where will be the direction of moment now?
Sir, it's gonna be opposite.
Opposite mean where? If you rotate the right hand finger
Sir, downward.
downward, the direction will be downward basically, right? So this is the one way. There are two ways to specify the direction of moment. One, we can say clockwise and anti-clockwise, right? And the sign convention for clockwise and anti-clockwise is in such a way, a-clockwise, right? Clockwise is taken as negative, whereas anti-clockwise direction of moment is taken as positive, right? Anti-clockwise is positive. This is the sign convention for the moment or the torque, whereas clockwise direction is taken as negative. And how to figure out the resultant moment, because there could be number of forces that are acting on a system. For example, you can see in this system there are three forces that are acting. One of the forces F1, F2 and F3. So how to figure out the resultant moment? Each force is contributing a moment. Let's say F1 is contributing M1, and this is a moment arm for this force with reference to the point O. Point O is the point of rotation. Similarly, F2 is the force about point O, and this is the moment arm, so that's contributing M2. Similarly, F3 is contributing M3. So how to figure out the resultant moment? You have to add up these moment. I mean the resultant moment MR, basically that will be, let's say uh, MR. I mean MR is basically the sum of the three moment, M1 plus M2 plus M3, right? All the three moments you add up, that will be the resultant moment, right? And what is the value of M1? M1 is related to F1 times D1. Similarly, M2 is related M2 F2 times D2. So this way you can add up all the three moments, then you can figure out like this one, right? But you have to see the direction of the rotation as well, that for example M1 is positive or negative, M2 is positive or negative. You can see M1 is in the counterclockwise direction, right? So this will be positive, right? So F1 times D1 will be positive, whereas M2 is in the clockwise direction, so this will be negative. Similarly, M3 is again in the counterclockwise direction, so this will be positive. So one moment will be negative and the two moment will be positive. So we have to see that if you simplify, what is the overall direction of the resultant moment, the value that you will calculate finally, that will indicate the direction of moment of the resultant. If the value is positive, that will indicate that the direction of the resultant moment is in the counterclockwise direction. If the direction, if the value is negative, that will indicate the direction of the resultant moment in the counterclockwise direction, right? Now, let's say we'll see different scenarios, and each scenario will try to calculate the moment about point O. Let's say here is a figure, let's say A, and we have a force of 100 Newton. This 100 Newton force is applied about point O. So what is the value of the moment about point O? So we need force multiplied by the perpendicular distance. So force is 100 multiplied by the perpendicular distance is 2 about point O. So there will be 200 Newton meter of moment, right? This is very simple. What about this one? What is the value of the moment about point O? What is the value of the moment about point O?
50 multiplied by 0.75.
50 multiplied by 0.75.
Multiply by
Yeah, multiply by
0.75.
0.75, because the perpendicular distance about the point O is 0.75. What about here? What is the moment now about point O? What is the value of the moment about point O?
40
How 40?
multiply by 40 is the weight, sir. 40 multiply by
40 multiplied by
uh
2 cos 30
2 cos.
no,
No, 2
that's
sin
incorrect.
plus 4
2 sin 30.
2 cos 30 plus 4.
Yeah, that's true. So that would be basically the moment arm, because we have to take the moment arm about point O. So the about point O, this is the line of action of the force. So basically we need a total distance from here to here, right? So the total distance from here to here is, 4, and then from here to here is 2 cos 30, right? So 4 plus 2 cos 30. So that will be the momentum. So if you simplify, that will give you the value of the moment about O. What about this one? Khizr is there?
Yes, sir.
Khizr, what will be the moment about point O?
It will be 60 into sine
60
45.
60 into sine 45, because this is the force and we need a perpendicular distance, right? Line of action of force perpendicular. So perpendicular distance is, this is 1 feet, so 1 sine 45, right? So next one, 287. What is the um, let's say 037? Who is 037?
Yes, sir.
Yes, please let me know what is the value of moment in this case. E, in case of E,
7
moment
into
about
3.
7 into 3. That's right, 7 into 3, because the line of action of this force is this one and the perpendicular distance from here to here is 3. So I hope you got the point how to figure out the moment. Now this is a simplest example. Determine the resultant moment of the four forces acting on the rod. So on the rod there are four forces. One of the forces 50 Newton, then 60 Newton, then 20 and then 40. So what is the resultant moment about this point O? So resultant moment mean we have to figure out the moment about point O. So we have to see that what is the contribution of each force. For example, this is 50 and the moment arm about the O is a 50 into 2. So 50 into 2. And then we have to also see the direction of this moment. The direction of this moment is about O is in which direction? Clockwise direction. So it will be negative, right? And then we have to see about this 60. So 60 is along the that point. So the moment because of this 60 Newton force is how much?
0.
0, because it is along the line of action of the force along that point. So no moment will be produced because of the 60 Newton. And then we have 20 Newton force and the perpendicular distance for the 20 Newton is this much. Right? This is the perpendicular distance for 20 Newton. And this much mean if the length is 3 meter, then the perpendicular distance is 330. And because of that, again the direction of rotation is clockwise. So because of the 20, the direction of will be negative in the clockwise direction. Right? This is in the clockwise direction. What do you think? Clockwise or anti-clockwise?
Anti-clockwise होगा sir.
Anti-clockwise, because this is the moment arm, right? So because of that moment arm, that will be anti-clockwise. So it will be positive. So that means 3 sine 30. And then about the 14 Newton. So this is the moment arm for 14 Newton. So moment arm, so this rotation is in the clockwise direction. So this will be negative. So 40 times, right? The moment arm is how much? 4. What is the moment arm for 40?
4 plus 3 cos 30.
Yeah, 4 plus 3 cos 30. That's true. So you know how to calculate the moment. That's very good. So that's called that will be the total moment. So minus, then plus, and then minus. So you will see that the overall value of that torque is in negative direction. So this negative sign indicates that the resultant moment will be in which direction? In the clockwise direction. So this is the clockwise direction. Right? If the moment is negative, that will indicate that the overall resultant moment is in the clockwise direction. So let's try to calculate about this one. This is problem 4-6. The crane can be adjusted for any angle 0 to 90. So this is the crane angle. I mean, crane can be in the horizontal direction. When it is in the horizontal direction, that means the angle is 0. When it is at the vertical position, so that means the angle is 90. So the angle can be changed from 0 degree to 90 degree. And any extension from 0 to 5 meter. So that means this boom can be, that x value can be changed from 0 to 5 meter. For a suspended mass of 120 kg, so the mass is 120 kg, determine the moment developed at A. So we need to figure out moment of the weight about point A as a function of x and theta. So the moment as a function of x and theta. What values of both x and theta develop the maximum possible moment? What is the maximum possible moment about A? Then compute this moment, maximum. Neglect the size of the pulley at A. So you can neglect the size of this pulley at A. So first of all, you need a moment about A, right? You need a moment about A as a function of theta and as a function of x, right? So we can figure out the moment about A, like let's say if we, I mean here is that weight, let's say the weight is acting downward, that force, we can convert that weight into force, we can multiply 120 with 9.81, so that will become weight. So 9.81 multiplied by 120. So that means we need this distance because this is a perpendicular distance. We need a perpendicular distance for this one. So if you have like this boom up to here is like this is 1.5, the total is 9, so the remaining will be 7.5. So 7.5 plus x, 7.5 plus x will be from point A to up to point B. So that will be the length. But we need a perpendicular distance from this one. So that will be 7.5 plus x into
Cos theta.
cos theta. Yes, that's true. So then you have to multiply that moment arm with that force. That will be the moment in terms of x and theta. Then when will be the moment maximum? What do you think? When the x is fully, I mean, what is the possible maximum value of x?
When x is equal to 5, theta is equal to 0.
Yeah, right. When 5 is equal to x and theta is equal to 0, because that when it will be in the horizontal condition, then the moment arm will be maximum, right? So in that case, the moment produced will be maximum. So this is the moment about point O as a function of theta and x. This is basically 7.5, right? And in second part, how to calculate that value when x is equal to 5 and when the theta is equal to 0, that will give you the maximum possible, and that maximum possible value is equal to 14715 Newton meter, right? And the direction is in this direction, right? That direction means clockwise direction, right? So it is mentioned that the direction will be the clockwise direction because moment is a vector quantity. So you should know what is the direction of that vector. So moment is a vector, so that in that case the direction will be in clockwise direction, right? And then we have, I mean, cross product, just like a scalar product. In scalar product, we let's say there are two vector A, B, and they're making an angle theta. We define the value of the scalar product. Now again, we have a cross product. Now uh, the cross product mean when the two vector they are their product is again a vector quantity. We call that a cross product. Say if we have two vector, let's say A and B, then A cross B, if give you another vector, then we say is a cross product. And mathematically, the cross product is equal to the magnitude of A, magnitude of B, and the sine of angle between them. So this is the magnitude, right? But since C is a vector, it must have a direction as well. So the unit vector will tell you the direction of the vector C, right? So this is AB sine theta is the magnitude of C, and UC will tell you the direction of the C, right? So this is the magnitude, and the unit vector will indicate the direction. I mean, A cross B mean if you curl your finger of right hand from A to B, that means A cross B, right? Theta is the angle between them. Then the thumb will indicate the direction of the C, which is perpendicular to the plane of A and B, right? That will indicate. Similar in scalar case, A dot B was equal to B dot A, but in this case, it is reverse. Like if you want to calculate B cross A, then the direction of the C will be in the downward direction. So this is A cross B. So this is B cross A, right? So you can see the direction is in the reverse direction in case of cross product. And then in terms of because when you say cross product, then the Cartesian vector, since they are also vectors, so there is a possibility of the cross product of the Cartesian vector as well. Like AI cross J will give you certain value. Similarly, I cross J will give you some certain value. So there is a rule, like you make a circle I, J, K. So if you take the product I cross J, then you will get K. K cross I, then you will get J. And if you reverse the direction, let's say I cross K will give you minus J. So this direction will give you minus, and this direction, I mean I, j, k will give you positive direction. I hope you understand this, because these are, you're studying from the high school, even you study in the calculus as well. So you know these things, that I cross j will give you some k value, and if the same Cartesian vector takes the I mean the cross product, that will give you the zero vector. I mean the a cross a, if there is a vector a, if you take the a cross a, that will give you zero value, because the cross product of parallel vector is equal to zero, because the magnitude of the cross product is a b sine theta. So sine of theta means sine zero is equal to zero. That's why the cross product of the parallel vector or the linear vector is equal to zero. And we know that how to figure out the value of the cross product. I mean, you can use this value this way also, and you can make a matrix as well, like I, j, k, then the component of the first vector ax, ay, az, then the component of the second vector bx, by, and bz. And you know how to open the matrix. I mean, first you have to take the first you have to take the I multiply by ay bz minus az by, and then minus j, second one minus j, right, and then ax multiplied by bz minus az multiplied by bz, and then plus k, right, ax bx by minus ay bx. I hope you understand this, how to do the vector product. Right, this is a vector product basically of two vectors. You can use the matrix, or you can simply use one by one product. I mean I cross j, so the value will be k. Right. So in case of moment in 2D, we use a scalar formulation. But if you try to calculate the moment in the 3 dimensions, then we'll try to use the vector formulation. So let's see how can we apply the vector formulation for moment of a force, right? Now let's say here is a force. Now we'll try to use the vector notation and 3 dimension. So when we say 3 dimension and vector notation, then this force is a vector. Vector mean it will have 3 component, like in terms of I, j, and k. Similarly, this moment arm r will be again a vector now, right? And it will also have 3 component I, j, and k. And if you want to figure out the moment, then you have to take r cross f. So this is basically the application of the cross product. Like there are many vectors, there are many quantities where you need to take the cross product between the two vectors. Like this is the application of a moment, that if you have two vector, one vector is the position vector, another vector is the force vector. So if you multiply, if you take the cross product of the two vector, then the result will be another vector, which is called moment. Right? So this is the application of the cross product. That's why we study the cross product. Right? So in that case, r will be a vector and force will be a vector. So simply you take the cross product, like r cross f. Right? Similarly, this one. Right? This tells you about the direction of this. That is a force. Right? In case of scalar, you always look for the perpendicular distance d. But if you're taking the vector notation, then you should not worry about the perpendicular distance. You just convert on any point on the line of action of the force. You convert that position vector into a you got the position vector, and then the force as a vector. Then you take the cross product, that will give you the moment in 3 dimension. Right? Just like this one. And there is another concept. We already studied this principle of transmissibility, but let's just to revise you that if there is a force, let's say this is a line of action of any force, a line of action of the any force, and because of that force, let's say we want to calculate the moment about point O, then we need a moment arm. In a 3 dimension, you can take any of these moment arm. You can take R1 as a moment arm, or you can also take, R1 cross F. This will give you a moment about O, right? This will give you a moment about O, because this is a position vector, force is a unit position vector. But you can also take, excuse me, please mute. you can also take R2 cross F. This will give you the same answer. Similarly, if you take R3 cross F, right, this will give you the same answer. So that's called the principle of transmissibility, that in the 3 dimension you can take any of the position vector on the line of action of the force. So whatever is the position vector, and if you take that cross product, that you will get the same answer. That's called the principle of transmissibility. Right, so you can see it has the same value whether you take moment arm r1 or you take the position vector r2 or you take the position vector r3, but the condition is force should be a vector and these position vector should be in the vector form, and you take that cross product, that you will get the same answer. Right, so in Cartesian vector notation, let's try to generalize this. Let's say this is a force F, and this force can produce moment about point O. So this is a position vector which is, I mean, on the line of action of this force. So if you take the cross product like R cross F, then you will get the value of the moment about O, right? I mean, in terms of graphical representation, this force has 3 vectors. Similarly, this position vector has 3 components. So you can see this force F has 3 components, one along y-axis, one along z-axis, one along x-axis, fz. Similarly, this position vector, this r, will have the 3 component like rz, rx, and ry. So if you take the cross product, let's say that means r cross f, so I, j, k, and since this is r cross f, so first will be the r component, rx, ry, rz, then is f, then the 3 component of force, fx, fy, and fz. So 3 component of the force vector. So if you simplify the method I described in the previous slides, like how to take the cross product, like first I, then the j minus j, then the k. So you simplify, you will get this one, right? And how to get the resultant moment of a system of forces, because there could be number of forces, you have to add up the moment. Like here we have 3 forces, so f1, this is r1, f2, this is r2, f3, so all are in vector form. In 3D, r should be in vector form. So first moment will be m1, so m1 will be equal to, this is a vector now, this will be r1 cross f1, right? Similarly, M2 will be R2 cross F2, R2 cross F2. Similarly, M3 will be equal to R3 cross F3, right? F3. And finally, the resultant moment MR, you have to sum up all the 3 moment vectors because these are the vectors. So M1 plus M2 plus M3. Right, so that will be the resultant moment. So you have to add up all the vectors. Right, this is the resultant moment. Now let's try to solve a couple of numerical problems related to the moment in 3 dimensions. Now you can see in this example we have the curved rod. So this is a curved rod starting, this is fixed here. You can see these are the bolts. So this is fixed at point A, O, and there is a point B which indicates the radius of that curved pipe, and then there is a point A where a force F of 80 Newton is acting. At a force of F, 80 Newton is acting. Determine the moment of this force. What will be the moment of this force about point O? Right? Also find moment about point B. So first of all, what is the moment about point O and moment about point B? Right? So you have to figure out that. So basically this is the line of action of that force. So in order to get the moment about point O, let's say moment about point O, what you need is, you need a position vector, I mean the moment arm. So moment arm is possible a straight moment on this one. This is possible even from point O. if this is the line of action of that force which is meeting at point C, so even from OC is also a moment arm. So we also take a position vector ROC cross that force, right? So we need vector this one and the force vector. So how can we get a force vector? For example, this force vector, this is a numerical value, right? How can we convert this numerical value into a vector first? We need a unit vector here. Unit vector mean we cannot directly get a unit vector. We need a position vector first. Let's say a position vector, let's say CA. We need a position vector CA. To get the position vector CA, we need the coordinates of A and coordinates of C. Let's say what are the coordinates of C? Anyone? What are the coordinates of C?
So 3i,
3I,
3j, 3i,
hmm,
and
3I and
3 sine 45j.
no, I'm asking about the coordinates of C.
Oh,
Sir,
C.
sir, it will be 4I, 0
4I,
0j
0J, very nice,
Minus
minus
2.
and
minus 2k.
minus 2k. That's true. So these are the coordinates of C. What about the coordinates of A? What will be the coordinates of A? Because for coordinates of C, I mean, you have to start from the origin. You start from the origin. How can you reach C? You have to move in the x direction. You have to move in the x direction up to here. So that means 4. So 3 plus 1 means 4 in 4I and then downward mean minus k direction, minus 2k. So 4I minus 2k. So that will be the coordinates of C. Similarly, what will be the coordinates of A? That's very simple, I think. Coordinates of A, they are very simple. What are the coordinates of A?
3i
3I plus
3I
plus 3 sine 45j.
plus 3j होगा sir.
3I. I mean, this is
Sorry,
Plus
3 over, sir.
plus 3j.
yeah,
Plus
3I plus 3j. That's true, right? So these will be the coordinates of A. So can you figure out now the position vector CA? What will be the position vector now? 4I minus 3I. How much is 1I? Right, 1I. And J is 0 here. 0 minus 3J means minus 3J. And then minus 2K. Right. So these are the coordinates of, I mean, the position vector of RCA. Then what will be the unit vector? What will be the unit vector of this force? Because we need the force in a vector form, we need a unit vector. So we have to divide this position vector with its magnitude. And how we get the magnitude? I mean, if you divide that I minus 3j minus 2k with its magnitude, and the magnitude will be equal to 1 square plus 3 square
Square root 14.
14 plus 2 square, and
Square
then
root 14.
okay, will be the unit vector now. So now can you get the force now? Force vector. So force vector will be equal to the magnitude of the force. Magnitude of the force is 80 times the unit vector, and this is the unit vector. You can use this. I mean U. Let's say UCA. So that now the force is in the vector form, but we need OC in a vector form. So what is the value of the OC? What is the value of the OC? That position vector. That's a moment arm. Moment arm mean any position vector which is on the line of action of that force. So OC is a position vector. So OC mean 4I. I mean this one 4I minus 2k. 4I minus 2k, and force is Now both are in vector form, force and this one. So simply you take ijk, and then first write down 4 0 -2, and then the coordinates of force that you will calculate from here, right? So this way you can get the moment about point O for force B. And how can you get the moment about point B? What do you think? How can you get the moment about point B because of this force? What do you think? How can you get that moment about point B? Anyone?
No idea, sir.
Now, for example, the same procedure, like to get the moment about point O, you need a position vector which touches any point on the line of action of force. It could be this one, it could be even OA, right? It could be, we use the OC, right? We use this OC, right? Now it says calculate the moment about point B. So that means now from point B we need a position vector that lies on the line of action of this force. So from point B there are many options. One of the option is, like, let's say the position vector could be like BA, right? There could be position vector BA, because there should be a point from B which lies any point on the line of action of the force. So one could be BA, another option could be from BC. So what is you need is you need basically the first the coordinates of point B, because just like this one, to get ROC we need the coordinates of O and C. O is 0 0 0 and C we already calculated. So just you need is the coordinates of B, right? So how can you get the coordinates of B? Anyone?
We will make the components of this distance 3.
Yeah, right. Because we know the angle. Let me explain that. We know this distance is 3 meter, right? From 3 meter, let's say parallel to Y, that will be the distance from here to here, right? And parallel to this one, right? And this will be the distance from 0 to in the x-axis direction. This will be the distance parallel to y-axis. What is the problem now? We know the total distance is 3 meter. So how much is this much? What will be this value from here to here?
3 cos 45.
Very nice. 3 cos 45. So this is 3 cos 45. And how much is this one? From here to here? 3 sine 45. Yeah, this will be 3 sine 45. So that means total is 3. So out of 3 you minus this one. So this will be giving you the I component. So I is 3 minus 3 cos 45, and similarly y direction, in y direction will have 3 sine 45. So then you can get the coordinates of B. So once you get the coordinates of B, then you know the coordinates of A as well. So you can get like any of the position vector. You can also get like BAB, the position vector AB, right? That will be, you minus 3I minus the coordinates of B, then you will get RB. Then you take its magnitude, right? Sorry, you just need that moment arm. So just take the cross product and then you will get the value of the moment about B, right? So this is, just to explain you, first we calculated RAC. This is from A to C, the unit vector. Once you get the unit vector, then you convert that force into a vector. You need the magnitude of this position vector, then you can divide this with the magnitude, then you will get a unit vector. This is a unit vector. So once you have the unit vector, then you multiply the force with the unit vector. So now the force in the vector form. Then we need the cross product. So ROC. So use that ROC and you simplify, then this is the value of the moment. Okay. Now calculate the value of the force. The force is 80 Newton, which is acting on this pipe. Determine the moment of this force about point A. Right, we need to calculate the moment of this force about point A. So that means from point O A, we need a moment arm which lies on the direction of force. So this is the direction of the force, line of action of the force. So there should be a moment from this point which lies on the direction of that force. So let's say this is that moment arm. Let's say we need to first calculate RCA. Let's say RCA, right? Because moment about A is equal to the moment on CA cross force F. But this both should be in vector form. This moment should be in vector form and the force should be in vector form. Now for the force, this is the force. Since we know the angles, so it is very easy for us to convert into vectors. For example, this force has several angles. For example, if this is the angle, this angle is 30-degree angle. So it is very easy to calculate the component of the force in the z direction. This component is in the z direction, right? So this component can be easily calculated. What is the value of this component?
80 sine 30.
80 sine 30. So this component is in the z direction, negative z direction, sorry. This will be minus k, right? And similarly, we need the other three component as well. Along the x-axis. So this is the component which is along the x-axis. Parallel to, this is x-axis. So this is the component which is parallel to x-axis. How can we calculate this one? And similarly, this is the component which is parallel to y-axis. How to calculate this one? Because we need three components of the force. This component is only along the k direction, right? We need a component which is parallel to x-axis and a component which is parallel to y-axis. So how to calculate these two components? What do you think? Anyone?
80 cos 30 sin 40.
80 cos 30 sin 40. Yes, you are right. Basically, since this is a force, right, we use that force 80. Since this is in front of the angle, so this will be 80 sin 30. What about this one? What is the value of this one? This value, this
80
line.
cos 30.
Yeah, this will be 80 cos 30, right? This will be 80 cos 30. Now this is a hypotenuse. This is a hypotenuse of this triangle, which is making an angle 40. So now we can use this hypotenuse to get this one. So this will be sine 40 because this is in front of that angle. So 80 cos 30, 80 cos 30 sine 40, right? So similarly, this one will be like similarly base. This is base. That means 80. Again, we'll use the hypotenuse. 80 cos 30. 80 cos 30 cos 40. So now we have the three component of the force. One is along the z direction k. One is along the x direction I. And one is along the y direction j. Right? J will be positive. X will be again, what do you think? X will be positive or negative?
Positive.
Positive. And K?
Negative.
K will be negative. So we have three components. So now that means we have converted this force, the scalar force, into a vector force. And how to get this one now? This moment arm. How to get this moment arm? We know the coordinates of A is 0, 0 because that's at the origin. Right? That's at the origin. How to calculate the coordinates of C? How to calculate the coordinates of C? Right? How to calculate the coordinates of C?
550I.
550I. Let me see. I mean, in the I direction will be
400J.
yeah 400 J. Yeah, right. And then
200K.
200K. Now,
Minus
but we
200.
have to,
Minus
I
200.
mean, take into consideration the direction as well. This is minus 200K. I mean, 400 Y, I mean J, positive. Similarly, positive 550I, but minus 200K, right? So again, now you can also get this in the vector form because you know this one and this one. So simply and the position vector between 550I, 400J minus 200K. So just take the cross product, that will give you the value of this one. I mean the moment, right? So let me erase this. So we converted this force first of all into vector. How? We calculated the unit vector, I mean all the three component, and we multiply with that force. And then we calculated the position vector, this RCA, right? And then we take the cross product, and that is the value of the moment about O. So this is in 3 dimension. We know the moment calculated about O A has 3 components, one in I direction, J, as well as in K direction. Right? Can you calculate this force? Can you solve this? This is 4-42. So if we have a, let's say, strut AB, right? If this comes, let's say we want to support that hole, that's the cover, main hole cover, right? Or the hatch door, you can say. The diameter is given for this one. The diameter is 1 meter. And what is the moment of this force? I mean this strut force about point O. So we need to calculate about point O. Moment of this force. How can you calculate the moment of this force? What do you think? Anyone? Moment about O because of that force. Yes, anyone? How to calculate the moment of this force F about point O?
सर पोजीशन वेक्टर
R
फाइंड करेंगे ए बी से, ए बी और ए का, और
A, B or
ओ ए.
O, A ka? No, I'm asking about the formula first. What is the overall? Because
OB,
we need to
ROB
calculate
times F.
R
OB times F.
OB, yeah, times F. Yeah, you are right now. Basically, because this, if this is the force, then we need any position vector on that force. So this is basically the position vector OB and F. So basically, we need, what we need is we need two vector, ROB vector and a force vector. So that means for ROB, we need the coordinates of B. What are the coordinates of B? One of the coordinates is this one. I mean, we'll start from here, then we can go up to here, and then we have to move in the upward direction, right? What is the horizontal distance? What is horizontal distance now? If this is 1 meter,
1 meter.
now this is 1 meter. No, this is not 1 meter because this is 1
1
meter.
cos
From
30.
O to B is 1 meter, and we know this angle is 30 degree. So what is this one? Horizontal?
1 cos 30.
1 cos 30. Yes, this is 1 cos 30. What about the vertical one? Vertical one?
1 sin 30.
1 sin 30. Yes, this is 1 sin 30. Right? So these are the coordinates of B. And we also need we also know to convert that force, we need a unit vector, and that unit vector will be AB. Right? To convert this scalar value of this force, we need a unit vector along that direction. So we also need the coordinates of A. What will be the coordinates of A? Like let's say here we need a parallel to A. Let's say this is a parallel to
0,
A. Right? This
1
is
cos
a
30.
parallel to A, and parallel to A mean this is 0.5. This is 0.5, and that angle is 30. So what will be the value of this one?
0.5
0.5
sin 30.
sin 30.
Yeah, 0.5 sine 30. Right? This is 0.5 sine 30, and the direction is in x-axis. And then we also need from here to this distance. From here to here is half is 0.5. Right? This is 0.5. And then from here to here is how much?
0.5 cos 30.
0.5 cos 30. So the other coordinate will be in the y direction 0.5 plus 0.5 cos 30. Right? 0.5 cos 30. So again we have the two coordinates of A. One is, I mean, in y direction is 0.5 sin 30, and y direction it is 0.5 plus 0.5 cos 30. So again we can get the position vector, right, RBA, and then we divide that position vector with its magnitude, RBA magnitude, then we'll get a unit vector, right? And that unit vector will convert this force into a vector force, right? And then this is already, we know that this is OB, so we know the coordinates of OB. So can you calculate that force, right? So in this case, we need first of all the position vector ROB and ROB, right? Similarly, then we converted the force into vector. We multiply the force with the unit vector, right? So when we multiply, then this is the force. Then we take the cross product. We can take cross product either using the OB, or we can also use OA, because both lie. We can also use OB because that lie on the line of action of the force. We can also use OA. So both will give you the same answer, because both lie on, I mean, both will give you the same answer because both lie on the line of action of the force. So is that clear?
Yes, sir.
Yes, sir.
Yeah, if you have any question, you can ask me. So next time